So last time we discussed the scientific method, and today we are going to be applying the scientific method to learn more about gravity. So our question for today is, does the mass of an object affect how fast it falls? From my background research, I learned that all objects have gravity, and that the bigger the mass of an object, the bigger the force of gravity it exerts on other objects. This is why we stay on Earth instead of floating off into space, but why we're not stuck to each other. The Earth has a much larger mass than a human person. I learned about the distinction between weight and mass. Weight depends on the specific amount of gravity that an object is experiencing, whereas mass is constant and it depends on the amount of stuff or matter that an object is made of. So, for example, if a person was on the moon, they would weigh less than if they were on the Earth, because the moon has a smaller mass than the Earth, and therefore the force of gravity that a person experiences would be less on the moon than it would be on Earth. However, the person is still the same size on Earth and on the moon, so their mass would remain constant. My hypothesis is that heavier objects fall to the ground faster than lighter objects. So for our experiment today, we are going to be dropping two containers of the same shape and the same size from the same height, and we are going to compare how fast they fall in relation to each other. So the only thing that's different between these two containers is going to be their weight. So we have here a scale in front of us, and we're going to measure the weight of both containers. I'll turn the scale on and get started in just a second. So here's our first container, and you can see it measures in at 0.3 pounds. This is our second container. It contains couscous. You can use any sort of filler that you like. You could use rocks or sand or rice, just whatever you have on hand. So this container is weighing in at 2 pounds. We're also going to check the mass really quick. If you can see on the side of the scale, there's a little arrow next to the number, and that is pointing to the pounds unit, but on top of that is a unit for kilograms, which will measure the mass. So I'm going to switch around the units real quick, and then we will measure them just one more time so that you can see the mass as well. So the empty container has a mass of 0.15 kilograms. And the container filled with couscous has a mass of 0.9 kilograms. So I am in my garage right now, and I'm about to perform the experiment, dropping these two containers from the same height. I'm going to be dropping them from the third metal bar up. I'm going to align the top of the container with the top of this metal line right here, and I'm going to drop them from there. I have already measured it. It is 62.5 inches, or about 1.59 meters high. So let's get to it. So I did not time each ball while I was in the garage because I only had two hands and I needed both of those to do the experiment. So I got the times by reviewing the video footage that I took, and I used a timer while watching the video footage. I timed each fall 3 times so that I could get better accuracy, and what I found was that the empty container took about 0.3 seconds to fall, and the container filled with Cuscos took about 0.31 seconds to fall. That's 1/100 of a second, so it's pretty negligible. They basically fell at the same rate. Even if you want to really pay attention to that 1/100 of a second, the empty container, the one with less mass and less weight, fell faster than the one with more mass and more weight, the one with the Cuscos. So, but they basically fell at the same rate. So my hypothesis was disproven. I am not going to be repeating my experiment today because even if I went back and I revised my hypothesis, the experiment and the results would be exactly the same, so I don't need to do that today. One thing that I wanted to mention, if you were writing this up in a formal lab report, and your conclusion, because there's a slight time difference between the falls, you could mention that perhaps that's because of human error in timing, or perhaps one was about 1/2 inch higher when you dropped because you weren't accurate enough with your height, or maybe one twisted and fell kind of a funny way and the other one was more flat and that affected it. But I am not going to do a formal lab write-up today because for my communicating my results, this video is me communicating my results. So I hope everyone has a great day and happy experimenting!